I'm Steve Gruber. I'm director of our Center for Precision Medicine at City of Hope National Medical Center in Duarte, California.
Yeah, I'm Dr. Jeffrey Trent. I'm also a professor at City of Hope, but also the president and research director of TGen, the Translational Genomics Research Institute, which is a genomics institute of the City of Hope.
Jeff, I wanted to begin by asking you, when TGen joined City of Hope, it created unique synergies for delivering precision medicine to patients. Can you begin by telling us about what TGen delivers with respect to precision medicine for patients?
Well, one of the foundational elements that you really need to be able to make the type of personalized medicine more precise, and what we frequently call as precision medicine, is to capture genomic and genetic information that can be useful for the patient, and especially in regards to the physician of the patient making the informed decisions that they need to, certainly around elements of diagnosis, but also prognosis. So what TGen has added is that for about a decade, we worked on the development of capturing as much information as we possibly could on every patient. So rather than starting with a small number of the best known genes that have the greatest functional information and the clinical relevance, let's capture everything. Let's try to look as deeply as we can, as broadly as we can, all 20,000 of our genes, and see if we can build that into a test that ultimately would be approvable by CMS and others. And that's really what we brought to City of Hope, was how do we get that deep look into an individual's genome to be able to provide to physicians like you, Dr. Gruber, in the clinical care of your patients.
Jeff, that's such a great summary, and I love the way you described the fact that really the goal here is to study everything to be able to provide maximal information for patients. And one of the things that I'll just say that we are really committed to here at the City of Hope is not just being able to study all the information that's carried in the genomes of our patients and the tumors that we are caring for to treat effectively, but also to do that universally and to make that universally accessible to our patients. One of the things that I think is really on the horizon for cancer care, and Jeff, I'd love to get your comments about this, is the way in which cancer care is really being transformed by genomic information, both information from the DNA that we inherit, as well as the DNA that's really quite specific to tumors. Could you just describe your vision, Dr. Trent, for how in the future we believe that this combination of information will be an incredibly powerful way to help care for patients?
Yeah, so without question, when we look at a cancer patient, we're dealing with two genomes. We're dealing with a genome you were born with, we frequently call it the germline DNA, and then of course we're dealing with the genome of the cancer cells that have gone rogue, and we need to make such a positive information about. And it's still just, it's extraordinary in my mind that there's not enough alignment of these two genomes that work together and provide opportunities to not just understand those things that are unique in a cancer, but those things that are unique that we were born with, that can provide treatment opportunities. That is, we understand certain of these changes really do picture and help us decide which treatment to give, which treatment not to give, et cetera. And what, again, Dr. Gruber's program that he has at City of Hope attempts to do is to clearly capture information on both of these genomes, on every one of our patients, giving them the best opportunity we can for the maximum amount of benefit.
Jeff, I'm so glad you brought it to that specific level, because I believe that right now we are one of, if not the only, cancer centers that's really offering comprehensive genomic profiling for all of our patients that really concentrates on the DNA that we inherited from our parents, as well as the DNA from those tumors. But the thing that I really cherish about being at a place like City of Hope is the fact that we're not taking care of tumors. We're not taking care of an accumulation of mutations. We're taking care of people. And as we look at the complexity of all of the things that drive the clinical conditions that we care for in each of our patients, it's interesting to note that the more we learn about genetics, the more that we realize it's not just restricted to a few rare conditions that we knew had inherited contributions. For example, for a long time, we've known that breast cancer, ovarian cancer, colon cancer have a subset of those cancers can really be identified and attributable to inherited susceptibility. But through the work that you and others have done through the Human Genome Project, we're now finally being able to translate that genomic information to understand risk of other conditions, including the types of things that can help us protect heart health and other components of our health. Could you maybe just take us back to the days when you and others in the Human Genome Project were anticipating the value of deciphering the human genome and what it would lead to?
Yeah, so sure. So I had the privilege of being the scientific director. That meant I led the program at the National Institutes of Health that was located on the Bethesda campus, or the intramural program. And Dr. Francis Collins, who I had left the University of Michigan with, became the director, replacing Jim Watson, the Watson and Crick Nobel Prize winner who had started at that time, the center. It's now the National Human Genome Research Institute. And that decade for that government project that was ahead of schedule and under budget, so only took 10 years instead of about 15, only took about $3 billion instead of $5 billion. Still a government project that helped us get that first genome. So with that came the hope and expectation that this would not just be a collection of information or that end-to-end analysis of the first genome, but it would actually become the most useful textbook in medicine for perhaps the next 50 years or more. And I would argue for the first decade, it was hard to see the realization of that. And for now that we're 20 years out, for the last 10 years, we're recognizing every day how much this contributes to the medical management of our patients today and is going to contribute even more tomorrow. So again, those groups that are willing to even advance of the standard clinical care, provide as much information to every one of our patients as we can, are those that are ultimately going to benefit not just the patients of tomorrow, but the patients sitting in front of us today.
Well, precision medicine is still developing and evolving. And I'll just say that in our clinical practice here at City of Hope, we take a multidisciplinary practice approach that takes advantage of the expertise of each of the disease team leaders and experts that has really specific expertise about how to care for patients with any given tumor. But what you just described, Jeff, also describes the way in which we're accessing that great textbook of the human genome to be able to leverage that information through a more centralized approach where we bring in all of our experts into precision oncology tumor boards, where that information is centrally considered both for the DNA that characterizes the specific genomic landscape of what's driving a tumor's behavior, as well as inherited susceptibility. Could you perhaps describe the specific approach that you and your colleagues at TGen and at Ashion have indeed developed to subtract out information to highlight the features that are most likely to be actionable for clinical care?
So as I mentioned, when we deal with cancer, we deal with two genomes. And you really are trying to identify what are those unique changes that are driving an individual cancer and for which we may be able to match a treatment, or we might be able to make an even more accurate diagnosis. But and to some extent, we subtract out the information that you were born with that might somehow cause us to think that a change in the cancer is, and we've missed it because it happens to be a change in every single one of the 14 trillion or so cells that you have in your body. So if it's something that you were born with, we've got to take that into account. But we also got to be able to understand that there's times where what you're born with can give, again, a physician like Dr. Gruber the opportunity to make a decision on what to treat with, or again, what not to treat with. And so there are specific examples I know Dr. Gruber can give for when we can use this information most effectively. So what we add to the equation that's unique is, one is we make sure that we look at both genomes. We make sure we know what's coming from your germline, what's coming from the tumor. We also look at RNA, that's the product of DNA, which helps so much because many of our treatments now are targeted towards what we call, for example, fusions or other aspects. These are combinations of genetic changes that lead to a novel protein that we might be able to observe in the product of versus not. So I think I'll just say that once again, we're trying to provide the maximum amount of interpretable information that's as specific as we can provide it to our physicians to make the best informed decision they can on the patient sitting in front of us today.
I'm glad you mentioned the types of specific examples where genomics has really transformed cancer care. And just to give three specific examples, melanoma, subtypes of colon cancer, and ovarian cancer in particular are three terrific examples of where the genomic information guides us to therapies that have totally changed the outcome of patients with these diseases. And specifically for melanoma, the introduction of checkpoint inhibitors has totally transformed the way in which we care for patients with melanoma. Similarly, that same class of drugs works in a subset of patients with colon cancer that have a specific molecular fingerprint, as it were, that helps us identify those patients who are extremely likely to benefit. And a separate class of drugs called PARP inhibitors happen to work extremely well for patients with ovarian cancer who have a different signature that suggests that drugs like PARP inhibitors will work for patients who have either a specific somatic signature, which we can identify, that is the signature of the tumor itself, or in fact, the types of genetic mutations or pathogenic variants which can be inherited from parents, which suggest that you're very likely to be able to respond favorably to those drugs. That's the type of information we use really effectively with this type of technology. Jeff, one of the other things that you and I have spent a lot of time concentrating on with our colleagues here at City of Hope is how we can deliver this more broadly to the community and make sure that all of our community physicians are able to take advantage of this great work. And here at City of Hope, in addition to our academic medical center campus in Duarte, we have 31 community sites. And I wonder if I could just get your perspective about the overarching vision of the institution to make sure that we are transforming care, not just at academic medical centers, but in the community and nationally.
Yeah, so bringing this type of advanced care to the bedside of patients wherever they are, democratizing genomic information to the benefit of the individual patients is a critical aspect. I would argue City of Hope has some unique ways that they're working on that. One is, of course, just what you just said, which is 31 sites across a service area in the LA area of 17 million individuals is not enough, but it's a way to bracket across neighborhoods and programs to ensure that not just the major center at Duarte, but also the new billion-dollar investment in Orange County provide sort of hubs, but there really is a series of those spokes that go out into the community and ensure that we have a framework to deliver the same quality of care across the area and across our service area indeed. So I think the other is we are involved, a number of us at City of Hope, in the national engagement of the dialogue of how to ensure that these tools are used in a way that is logical, that physicians understand, that even the groups like Medicare, Medicaid, and private payers have seen the value and are able to ensure that the patient receives this as part of their standard care. All of those are important aspects that go beyond the time that we spend with our individual patients.
So Jeff, I just have two other questions that I'd like to raise with you in our short time together here today. One of the things that we've discussed here at City of Hope is how can we make precision medicine more precise for diverse communities? Could you describe the science behind the ways in which we can use genomic information to be really tailored to the populations that need it most?
So certainly I think people have become more familiar with and more accepting of the fact that your genetic ancestry plays a role in who we are. And so whether it's one of the quote recreational genomic tests like a 23andMe or Ancestry.com, it gives you a sense of really where your ancestry comes from, et cetera. The reality is that much of genetics and much of genomics has been built on studies in Northern Europeans, and it's critically important that we provide the same information, the same specific information as we look across other populations, particularly those that may be underrepresented in terms of the studies that we've done so far. So we're very involved at TGen in studies with Native American populations and Hispanic populations. At City of Hope, there's focus on both Hispanic and African American populations. And this is really just to say, as we look at this genomic information, we capture it, can we glean information that could be relevant to, whether you're an Asian background, whether you're an Indian background, whether you're, the European background. We want to make that playing field the same to really, just as you said, make this precision medicine more precise for every American.
And we're so fortunate here at City of Hope to have world-class leading experts in population genetics and genomics, and especially on the prevention side, to think about the work of people like Dr. Rick Kittles and Dr. Stanley Hooker and others as well who are contributing to these initiatives. Finally, I just want to ask you, Jeff, because you've been at the forefront of discovery for a long time. And here at City of Hope, we have such a successful track record of developing life-saving therapies, including technology that led to the development of synthetic insulin and 3 of the top-selling cancer drugs, Avastin, Rituxan, and Herceptin, as just examples from City of Hope technology. But when you think about discovery and the fact that City of Hope now holds over 450 patents that lead to the development of these new drugs, where do you see the future of the work that we're doing in precision medicine, being able to find the next set of targets and the next set of drugs that will lead to improvements in outcomes?
Well, as I mentioned, we have a critical need to be able to establish what we call real world evidence, which is to show not just can we identify a change, but can we identify a change and show its relevance clinically to its use, et cetera. So among those areas that I think we are making a difference is as we do identify these changes, diagnostics is going to be a critical window for the foreseeable future. Most of our focus with genomics has been on treatments, on therapies, and increasingly really the spectrum of diagnostics. That means, as mentioned a moment ago by Dr. Gruber, the cancer prevention side, making sure, are you at risk? Are you at elevated risk? But early detection of cancer. If you end up getting diagnosed with cancer, was your treatment successful? If your treatment was successful, do we have a way to follow to see whether there's any reason to think that there might be a recurrence of the disease? If you really have recurrence of disease, how do we inform in physician decision support, as we've talked about? So all of those are really fall into the more or less diagnostic category, and all of those require significant investment. And all of those are a major staple of what's being done at City of Hope.
Well, I will say the future is bright. We have our work cut out for us. But Jeff, it's so great to spend time with you and to be with you today. Thanks for your insights, and thanks for all the work that we're able to do together at City of Hope to transform the future of cancer care.
All right. Well, thank you very much.